Hello students, today we are going to see one topic in chemical bonding chapter, that is molecular orbital theory. In this molecular orbital theory, you must know some postulates about that. Simply you know that what is molecular orbital means, combination of two atomic orbitals called molecular orbital, isn't it? Whenever that atom plus atom molecule, no, likewise atomic orbital plus atomic orbital we can get molecular orbital. So it has two types, no, bonding molecular orbital, anti-bonding molecular orbital. So the orbital which has low energy is called bonding, higher energy is called anti-bonding. I given clearly. There is representation is sigma, pi, delta, no. Another is called sigma star, pi star, delta star. Okay, right. Then molecular arrangements you must know. Okay, molecular arrangements means this order is just keep in mind. Then only we can able to find out the bond order, stability, bond strength, paramedic or diametric, everything we can able to find out. This is very important. Okay, you just remember this one. Then only it will be very easy to find out the other things. Okay, right. Here one second. Okay, here bond order, molecular orbital, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px, pi 2py, sigma 2pz, pi star. Then after bonding is over, we have to put anti-bonding. So this one you just keep in mind. Wherever star is there, asterisk symbol, no, this is called anti-bonding. So this order we can follow up to total valence electron is what, up to 14. Okay, total valence electron up to 14. This trend we should follow. I given one more trend, no, down. There is a small changes in molecular orbital arrangements. Okay, so nothing but the pi to px, no, this pi to px, are you following? The pi to px and sigma to pz, no, sigma to pz. Okay, these two are interchange, that's all, simply remember. Okay, so sigma to pz it will come first, pi to px and pi to py will come next. That's all, these two only interchange, but everything same. Okay, now the fourth point is bond order. Bond order, nothing but what's the formula? 1/2 NB minus N of A. That's a formula for bond order. NB means number of electrons in bonding molecular orbital. Understood? What is NB? Number of electrons in bonding molecular orbital. No. Okay. Number of, write it here. Number of electrons in bonding molecular orbital. NB is called number of electrons in bonding molecular orbital. N of A is called number of electrons in anti-bonding molecular orbital. Understood? Right. Write it here. Just listen. Okay. So N of okay. N of A and N of B. Okay. Right. So just remember the formula 1/2 NB minus N of A. Okay. Then bond order, nothing but if any species having more bond order, that will be more stable. Okay, more stable. So that only I given one example. Bond order for hydrogen is 1, bond order for oxygen is 2, bond order for nitrogen is 3. So who is having more bond order? Nitrogen having more bond order, no. So that is more stable. Understood? So this and all just keep in mind. Okay. Then next one is another one more point. So I'll write it here. Just see. Sixth point is okay. That is bond order is inversely proportional to bond length. Understood? inversely proportional to bond length. Suppose if, for example, if we take nitrogen triple bond order, we found out 3. The same thing oxygen, we found out what bond order is 2. Then same thing we can find out hydrogen bond order is 1. Understood? Are you following? Bond order 1 means I put one single covalent bond, a double covalent bond. Bond order 3 means triple covalent bond. So bond length nothing but when bond order increases, bond length will be decreases. So simply you can remember. So nitrogen having more bond order, but bond length will be what? Less. Understood? Okay, nitrogen having more bond order, but bond length will be less. So then only I put bond order is inversely proportional to bond length. Understood? Right. Next one. So then suppose here this is all usually you are studying all the chapters. If you have paramagnetic, paramagnetic means suppose when you write the electronic molecular orbital arrangements, or if you put the electrons in the orbital, if you have any unpaired electrons, any single electrons in these arrangements, so that species we can say paramagnetic. Okay, suppose here diamagnetic means what? Diamagnetic means here all the electrons are paired, no single electron. So if you have any paired electron means we can say what? Diamagnetic. So this and all the postulates about molecular orbital theory. So now we are going to see a study about some application for this. So they'll give one molecule. In this molecule, what is bond order, what is paramagnetic, what is that is diamagnetic or paramagnetic. So that kind of questions they'll ask in this topic. Understood? Suppose for example, I start from hydrogen. Okay, hydrogen bond. Hydrogen means what is the total valence electrons in hydrogen molecule? Total valence electron in H2 is what? 1 hydrogen, 1, 2 hydrogen, so totally 2 electrons, correct or not? Okay, right. That electron we should fill up in this orbital. So what is electronic configuration? What is electronic configuration? That is, we have only 2 electrons. No, that 2 electrons we can fill up only in this orbital, sigma 1s2. Okay, this is bonding or anti-bonding. So this is called bonding, right? Now bond order. What is the formula for bond order? Bond order is equal to what? 1/2 NB minus N of A. Are you following? Right. 1/2. This is what? NB means number of electrons in bonding. So 2 minus 0. No electrons in anti-bonding, no. Simply you can say what? So we get one answer. Understood? Are you following? So in hydrogen molecule is bond order is 1. Understood? Right. Then is it paramagnetic or diamagnetic? In sigma, see the electron configuration. In sigma 1s2 1s we put only 2 electrons, no. So due only 2 electrons means that is paired electrons. So we can say due to paired electrons it is diamagnetic. Understood? Are you following? Due to paired electron, therefore